Okay, y'all. So we've now seen, I'll call it the longhand way of doing these dosage problems, although it's actually a pretty shortcut method, so long as all your units agree with each other. It's actually a really nice, straightforward shortcut way. But depending on the numbers in the problem, you can actually shorten it even more. And let me show you. I'm going to talk you through some of the shortcuts that I've noticed in here, and then we'll show you on top of me talking why it works with the longhand method, at least for the first one or two. So I skipped over number 3 earlier. Prepare 0.3 milligrams from a solution strength of 0.6 milligrams in 0.8 milliliters. Okay, so a lot of decimals, but don't get screwed up by the decimals. If you need 0.3 milligrams and the solution strength comes in 0.6, that means you need half a dose, right? That those 0.3 or 0.6 milligrams are floating around in solution. And in an entire bottle, which is 0.8 milliliters, there are 0.6 milligrams of it. If you need 0.3, you need half a dose. So you would need 0.4 milliliters. Now, if that kind of talking it out didn't make sense, check it out. You can still do it mathematically using our methods from before. Totally the same thing, get the exact same result. But if the numbers kind of work out, like some of these do, then you can use that shortcut. Let's skip down another one here. Number 6. Here's a good example. A dosage of 150 milligrams has been ordered. The solution strength is 100 milligrams per milliliter. So, you know that each bottle of whatever this drug is has 100 milligrams in it. You need 150. That means you need a full bottle plus a half a bottle. That's 1.5 doses. Boom! Again, you can work the math like we've done it on the board, but it works just fine mentally if you can do that math in your head. Now, I'm not saying you always can. Some of these numbers maybe have been handpicked to be kind of nice. I even noticed some of them like that don't look nice, like number 5 there. You need 52 milligrams of this drug in number 5, and it has to come from a 0.9 milliliter solution, which has 78 milligrams in it. Now, those numbers look horrific, 52, 78, but as I was looking at those numbers, 52 and 78 are actually nice because 52 is 2/3 of 78. So you actually only need 2/3 of a dose. So if the entire dose is 0.9 milliliters, the fraction of a dose you need is 0.6. Again, if this is making you sick to hear me talk through this verbally, you can do it by hand, just like we've done it on the board for the past few. It always works. The board method will always work. It's just that some of these things popped out at me as nice. Number 9 is another example. We need 0.25 milligrams. Our dosage comes in half a milligram per 1 milliliter. Well, 0.25 is half of a half. So you just need a half a dose. So you just need half a milliliter, or whatever that would be. That's probably got a fancy name in science. I'm going to call it half a milliliter because I don't know what the fancy name is. I hope that dosage problems viewed this way make some sense to you. Hopefully they're not quite as terrifying now. If you ever get stuck with math, shoot me an email. My name's Sean. I work in the math department up here at COCC, and I'm happy to answer any questions you got. Be well, y'all.